Hi, my name is Bailey Iannoni, and I will be going over my Lab 1. So let's get started. Okay, share screen. Perfect. Okay, first we're going to start off with my half adder. Okay, start simulation. So as they're both, we have two inputs right here and two outputs over here. We have A, B for inputs, and sum and cry for carry out as our outputs. We have an XOR function and an AND function right here too. Okay, so as you can see, A and B are both off, so nothing's happening currently, but if we turn A on, our XOR function is going to be true or on and make sum true on 1, everything. Okay, if we turn our B function on, our AND function down here is going to be true on all of the above for our carry out, but our XOR function is going to be false. So no sum there. And if B is on but A is off, our sum function is going to be on because of XOR, but our AND function is going to be off because it's an AND function. Okay, I'm going to show you my waveform for that. It was my half adder waves. Bam. Okay, half adder waves. And we're going to turn A, B, cry, sum on. There we go. Now we have them on our side right here. Perfect. And make this a little bigger. There we go. And if we click around, it's going to show us our little inputs and outputs over here, what they'd be. So B's 1, sum is 1, but carry out is 0 because that's our AND. Okay, next I'm going to show my incrementor function, which I think this is my full adder. I think it's this one. Okay, incrementer, perfect. So I have two inputs right here, A and inc for incrementer, and two outputs right here, cry for carry out, and Y is our output slash it's telling us what our bit equals. So we have a 4-bit wire right here. It makes this wire into 4 bits, and then it goes through our half adders in here because if there's 4 bits, we're going to need 4 half adders for each bit. And then over here, it's giving us it's turning our 4 bits back into combined or telling us what it is. So let's test it out. For A, we're going to make it, let's make it 6. There we go. And it goes through and over here, it's going to be 6. But if we turn our incrementer on, bam, it's going to be 7. Perfect. But if we wanted to test out our carry out function, let's make it, let's see, 15? Yes, 15F. Our F is going to be down here, but if we increment it, it's going to be a 0 and have a carry out. Perfect. Okay, now I'm going to show you my incrementor. Incrementor wave. Bam. Perfect. Let's open this up. A, B, cry, sum. Sum. Beautiful. Bam. Okay, if A is 0, but B is 1, our carryout is going to be 0, but our sum is going to be 1. Perfect. Okay. Next, we're going to go over my full adder. Yep, here it is. Perfect. Okay, we have we have three inputs and 2 outputs over here, A, B, and C in. C in is basically a carry in. And we have C out for carry out and sum. Okay, perfect. Let's start. So we have A. If A is on, it's going to make our sum 1 because over here we have an XOR function and it needs an odd amount of ons. And then down here we have our 3 and gates, and then we have an OR gate. An OR gate, you could have any of them could be true and it would go through. Okay. Next, we're going to turn on B. Our XOR gate is going to be false, but one of our AND gates is going to be true. This one down here is going to be true. So our OR gate's going to be true. So our carry out is going to be true. And then C in looks like that. We have all three of them on, so sum's going to be on because it's a odd amount that's on. And then we have carry out, which is going to be on because our OR gate and our AND gates are true. Perfect. Okay, now I'm going to show you my full adder. My full adder. Yes, there we go. Full adder. A, B, C, yes, beautiful. Bam, let me give you an example. Oh, there we go. A equals 0, B equals 1. Our carry in is 0, our carry out is 0, but our sum is 1 because that's where our XOR gate is. And lastly, we're going to talk about my 4-bit adder right here. Okay, as you can see, I already have 4 as an input. We have 3 inputs right here, A, B, and carry in. Okay, and over here for our outputs, we have carry out, overflow, and Y is basically our bit reader. We have this bit reader, and 3, so we have 3-bit eater. Okay, and then we have 4 full adders for each of our bits, and A and B are basically adding to each other and coming out as Y in hexadecimal. So we have 4 and 0. That means over here, 4 is going to be coming out as Y. But if B is something else, let's say B is 6, it's going to be A because A in hexadecimal is 10. And then we have some overflow here because our bit starts with a 1. 10A starts with a 1. Okay, and then to show my carry in function works, now our Y is a B and we still have our overflow right there. Let me give one more example to show my carry out. I think we could do 15. Yep, F and 6 with no carry in, that'd be 5, and we have a carry out over here. Okay, perfect. Let me show my 4-bit wave. There we go. And I'm only gonna put our important ones. There we go. Show you what that looks like. Okay. I think that covers everything. Thank you very much.